This is section 11.7. We're going to do a little bit more about probability. We're going to do and probability, and we're also going to talk about conditional probability. Independent events. If two events are independent, if the occurrence of either of them has no effect on the probability of the other. Most of the events that we've been talking about so far, they are independent. So let's suppose I have A and B, and they are independent. Then the probability of A and B, you multiply the two probabilities together. Remember in the last section we did probability with OR. If it's probability with OR, we would take the probability of A plus the probability of B. When it's and, you multiply, or you add. A US roulette wheel has 38 numbered slots. 18 are black, 18 are red, and 2 are green. The ball can land on any slot with equal probability. What is the probability of red occurring on 2 consecutive plays? So what we're looking for is the probability of red and the probability of red. So the first thing we have to do is probability of red. There are 18 red slots out of 38 slots total. And in probability means multiply. And we want the probability of red again. So we need 18 out of 38 again. Now when you're multiplying these, remember it's easier to simplify before you multiply. Notice 2 goes into 18 9 times, and 2 goes into 38 19 times. And when you multiply fractions, you're going to multiply the tops and multiply the bottoms. So 9 times 9 is 81, and 19 times 19 is, I have no idea. It happens to be 361. So the probability of red and then red is 81 out of 361. If we have more than 2 events and they are independent, we just keep multiplying the probabilities. So the probability of a baby girl is 1/2. We want to find the probability of 9 girls in a row. So the probability of a baby girl times the probability of a baby girl times the probability of a baby girl times, we would do that for all 9 babies. So 1/2, that would be the first baby. Second, third, should be a 2. Fourth, fifth, sixth, seventh, eighth, and the probability for the 9th is 1/2. We multiply that together. So multiply all the top numbers. 1 times 1 times 1 will give us 1. And on the bottom, not a clue. 2 times 2 times 2, that's 2 to the 9th, whatever that happens to be. 512. All right. So the probability of 9 girls in a row, 1 out of 512. Probability of something happening at least once. The way we calculate that is 1 subtract the probability that it does not happen at all. For example, we have the probability that South Florida will not be hit by a hurricane in 10 years is 0.047. We want to find the probability of at least once. At least once, we're going to use this formula, 1 subtract the probability that it does not happen, and we get 0.953. So probability that South Florida will get hit at least once in 10 years, that's actually a pretty good probability. Dependent events, this is different. Events are dependent if the occurrence of one does have an effect on the probability of the other. So if we have two dependent events, we want to find the probability of A and B. Notice this is slightly different. We do the probability of A, but for the next one, you do the probability of E given that A has already occurred. This will make more sense once we do an example. So suppose we have 20 chocolates in a box, and we have 5 of those are chocolate-covered cherries. What is the probability of choosing 2 chocolate-covered cherries? So if I want the probability of 1 chocolate-covered cherry, it would be 5 out of 20. But I want the probability of 1 chocolate-covered cherry and probability of 1 chocolate-covered cherry. Now, the thing with this is, I don't know about you, but when I have a box of chocolates and I take out a chocolate-covered cherry, I'm going to eat it. Okay? That chocolate is now gone. Okay? So once I eat the first chocolate-covered cherry, I started with 20 chocolates, but now I'm down to 19 chocolates because I've already eaten one. Now we have to think about how many chocolate-covered cherries there are left in the box. Well, remember the first one I ate was a chocolate-covered cherry. I started with 5. I've eaten 1. So there are 4 chocolate-covered cherries left in the box. So the probability of the first one is 5 out of 20. The probability of the second one is 4 out of 19. Because I've already eaten one of the cherries, I've already eaten one of the chocolates. So probability of chocolate-covered cherry and chocolate-covered cherry, you multiply. Well, they simplified before they multiplied, but anyway, you take the 5 out of 20 times 4 out of 19. 5 goes into 20 once over 4. The 4 goes into the 4 once. Multiply the tops. 1 over 19 is what you end up with. Just wanted to show you where those numbers were coming from. If we have more than 2 events, we do the same thing. 3 people are randomly selected, 1 person at a time. We've got 5 freshmen, 2 sophomores, and 4 juniors. So altogether, we have 11 people. Find the probability that the first 2 people selected are freshmen and the third is a junior. So we're going to select 3 times. Okay. We start out with 11 people. Once we've selected a person, then we have 10 people, and once we've selected another person, we're down to 9 people total. The first person has to be a freshman. So we started out with 5 freshmen. Then one of the freshmen is chosen. So now we're down to 4 freshmen. The third one has to be a junior. Well, we've got still 4 juniors still in the mix. So 5 elevenths times 4 tenths times 4 ninths. And you would multiply that, and remember you multiply the tops, you multiply the bottoms. 1, 2, 2 goes into 4 twice, and I'm seeing 8 over 99. Okay. Conditional probability. The probability of an event B, assuming that event A has already occurred, is called conditional probability. Again, all of this will make a lot more sense with an actual example. So conditional probability is the probability of event B occurring if we restrict the sample space, if we restrict what we're looking for to event A. So let's take a look. A letter is randomly selected. Find the probability of selecting a vowel given that the outcome is a letter that precedes H. So the given, that's what we have to restrict to. The only thing we can look at is the letters that precede H. So the only thing we have to look at is A, B, C, D, E, F, and G. Okay. Given that the outcome is a letter that precedes H, these are the only letters that precede H, that are before H. So how many are there? 1, 2, 3, 4, 5, 6. There are 7 letters. Find the probability of selecting a vowel. Well, we have 2 vowels, A and E. So the probability of selecting a vowel given that the outcome is a letter that precedes H is 2 over 7. Assuming that these numbers are representative of all U.S. women 40 to 50, find the probability that a woman in this age range has a positive mammogram given that she does not have breast cancer. So the only thing we're looking at is not have breast cancer. This is the only column we're going to look at. We're going to restrict it. We don't care about this. We don't care about this. So how many people do not have breast cancer? That's the number that goes on the bottom. No breast cancer, that's the number that goes on the bottom. That's the given. Now what we're looking for is positive mammogram. So positive mammogram, that's 6944. So probability and if we change that to a decimal, it would be 0.07 or approximately 7%. Your homework is 4 through 64.